This is our mini-golf diagram with the three main vectors A, B, and C, and the resultant vector D with their correspondent measurements and angles.
This is our golf course. This is the beginning point for our ball. This will be our ruler and our golf bat, and this will be the one that we use for measuring the angles. First vector will be, this is where the ball ended for the first vector, and the measurement for the angle is 44 degrees northwest, 42 centimeters. Now for the second vector, this is where the second vector ended. The angle is 27 degrees northeast, and the distance is 25.6 centimeters long. And now for the third vector, now the measurement of the angle is 23 degrees northwest, and the distance will be 43.4 centimeters long. Now for the resulting vector, the angle measures 14 degrees southeast, and the distance is 71 centimeters.
Now we're going to calculate in a graphical and analytical way the resultant vector. This scale is going to be 1 centimeter equals 10 centimeters. So the first value we're given is 42 centimeters, 44 northwest. So we use our protractor and measure 44, which is approximately here, and draw the line that has to measure 4.2 centimeters. To repeat the same process for vector B and C, starting from the end of the previous vector. B, we're going to measure 2.5 centimeters, 27 degrees northeast, which is in this quadrant. So we put our protractor right here and measure the 27 degrees, which is approximately here, and do the same thing for vector C, which is 43.4 centimeters, 23 degrees northwest, which is going to be in this quadrant. So we start from the previous point and measure the 23 degrees, that is approximately here. For the resultant vector, we are going to measure this distance, which is from the beginning to the end. So it's approximately 7.6 centimeters, which is 76 centimeters in our scale. And we measure the degree from here, which is approximately 53 degrees. And since this is the direction in this quadrant, this is the direction, northwest. And in the analytical method, we're going to do the table of values using cosine for x and sine for y. And we also consider the signs. For example, here, since it is northwest, we know that y is going to be positive and x is going to be negative. Then we do the addition, that is this for x and this for y. And for the signs, we also know the direction. We then use the Pythagorean theorem and we get this with the direction we got from here. And finally, for the angle, we use the inverse tangent.
There were some difference in the results of the graphical additions because we are prone to human errors or differences in the materials that we use. So the results are always going to be different. But in the analytical addition, the results were almost the same, and they only differ because of the decimals. The resultant vector represents the displacement.
So we did met the objective of the practice, which was to create a mini-golf and work with vectors. And we had several weaknesses. Firstly, starting off that we can work together because of the coronavirus situation. And we have another limitations, which are starting off with the decimals of the calculator that can affect the result. Also the working sheet you're working on, because it can affect the scale or something you're dealing with. And last but not least, the ruler that can even affect the result. Because of these limitations, we consider as a team that the analytical method is way better and more exact to work with.